So we're going to solve this differential equation by separation of variables. So you want to get your x variables on one side. So you want x and dx on one side, and you want the y and the dy on the other. Now the problem with this particular question, this equation, is that you want the dx in the numerator with x, not in the denominator. So, the easiest way to get dx out of the denominator is just to multiply both sides by dx. So now the dx is on the right side, and we want to move the x to the right side. So to do that, we need to divide both sides by x. We want to move the y to the left side, so we want to divide both sides by y. So what you get is 1 over y dy. And on the other side, we get 2 over x dx. I don't worry about the 2, it's just a constant. Now we have an expression in just terms of y dy, and then on the other side, we have an expression just in terms of x times dx, and now we can take the antiderivative of both sides. Okay, so that's going to be the way. So here, the antiderivative of 1 over y is going to be the natural log of absolute value of y. There's a plus c, but we're just going to move all the constants to one side. So I'm just going to hold off on that. I'm going to move the 2 out front, just factor it out. And then the antiderivative of 1 over x would be natural log of absolute value of x. And then I'll put both constants, arbitrary constants together on the right side, call it plus c. So now we want to solve this for y. So let's just do a little simplification here. If I use my power rule for logarithms, I can say this is natural log of x squared, and x squared is never negative, so I can drop the absolute value there. And then I'm going to use my logarithm rules with exponential functions, use the fact that they're inverses. I'm going to raise both sides onto powers of e, just like that. So here these cancel out, and we just get absolute value of y. On the other side, this is the same as e to the natural log x squared times e to the c. So where some students mess up here is they think this is e to the natural log x squared plus e to the c, but that's not how it works, right? So we're using exponential rules where, if you had like x squared times x to the fifth, then you would add the exponents, right? So we would say this is x to the 2 plus 5, or x to the 7th. And all we're doing is going backwards, right? So if the exponents are summed, if they're added together, then you can split this into a product where those exponents are on each factor of the product. So here you've got 2 exponents that are summed, so we put them together here. Just think about it. If you went this way, you're multiplying 2 numbers with base e, we would add the exponents, right? That's how we would simplify it. We're just going the opposite way here. We want to do this because we want this e and natural log to cancel out, and they do. So this becomes just x squared. And, for this one, e raised to an arbitrary constant, we could just call that another arbitrary constant, right? It's just a constant. E raised to any power is going to be a positive number as well. So we have a positive c. You could note that here c has to be greater than or equal to 0. Actually, it has to be greater than 0 because e to the c can't be equal to 0. Let me call that, just c has to be bigger than 0. right? So we get, we could just say that y is equal to some arbitrary constant times x squared. And in this case, we can say that c could be positive or negative because, really we should call this plus or minus c, but, when we get rid of the absolute value, but we can just say c is an arbitrary constant and let it be any constant. So here we could say, well, c could be any real number, okay? But this is the solution, pretty simple solution. Uh, you know, just because it's just a very simple equation here. But getting there was not very simple, right? We had to use a bunch of rules from algebra, pre-calculus, and calculus. Uh, so a couple places to get tripped up. First is the algebra, just getting these separated. So I would, pay special attention to that. And then here, these exponent and logarithm rules, I would pay special attention to those. We're going to use those a ton in differential equations. All right, I hope this helps.